Let's take a look at a more complex example using energy and momentum together, the ballistic pendulum. I'll draw a simple pendulum here, big mass m. Now I'm going to shoot a projectile like a bullet at a velocity v into the ballistic pendulum, little mass m. Now this will be a completely inelastic collision. The bullet goes in, embeds. I now have a combined mass of m plus m, and this will move at velocity big V. So this is my initial and final for my collision, and I can apply conservation of momentum to it. P initial equals P final. So initially I have little m, little v. In the end, I have the combined mass moving at velocity big V. Let me solve this. I'd like to find my initial projectile velocity, little v, which is just the combined mass times final velocity over the initial mass. Okay, but I don't know that big V. So I'm going to use energy to solve the problem. Once the collision has occurred, then I can apply conservation of energy. So again, I'm using energy with momentum. I have my combined projectile moving at big V. The projectile causes the pendulum to swing up. So now it's gone up a certain height from the center of mass. Let's say that height change is h. All right. Now here's my initial and final situations, and I'm going to apply conservation of energy. Initially, I have kinetic energy. 1/2. No, let's fix that. 1/2 times the combined mass, big M plus little m, times big velocity squared. In the end, I have gravitational potential energy, again, combined masses, g times h. Now notice I have the same mass on both sides, so let me just cancel that out. And I solve. Big V equals 2gh square root the whole thing. Now I can plug this back into my other equation and come up with an equation for little v. So let me get it there. Little v equals the combined mass m plus m times my big velocity 2gh square root all over the initial mass little m. There. Now let's put in some numbers and see what we got. I'm going to have a little mass of 20 grams, which I'll change into SI units, 0.020 kilograms. I have a big mass, and this is quite a bit bigger. Let's say, let's say 10 kilograms. Okay. Units are okay. And the height. We measured the height to go up, say, 10 centimeters, which again I convert to SI, 0.1 meter. All right, let's plug in these numbers and see what initial velocity we got. So 10 plus 0.020 times square root 2, and I'm going to use 9.8 for my g, height 0.1. Let me close this square root so I always forget. And over the initial mass. Let me get my calculator, punch in the values, and I always like to keep a couple extra digits during the intermediate calculation, but there I have it. So let me round off for my final answer. The initial projectile velocity was 700 meters per second. So I've used energy with momentum in solving a fairly complex two-stage problem.